Station number 3, systems of equations and those dreaded inequalities. The first one says solve by graphing. It doesn't just say graph, ladies and gentlemen. You got to figure out where they run into each other. So the first one, I'm going to go ahead and put a dot at 3, and then rise 2, run 1, rise 2, run 1. I'm also going to go down 2, left 1 a couple times to make a nice pretty line. I might need those points in a second. The second line, when you start at -4, go ahead and put a dot, and then go down 3, over 2, down 3, over 2. Well, I'm going to go ahead and go up 3, left 2 as well a couple times, and wouldn't you know it, I used that point that I already had. So, where do they run into each other? They run into each other at -2, -1. And now we have the solution. That's where they run into each other. The second one says solve by substitution. I would do this by substitution every single time because they already told you y equals. So if they tell you y equals, go ahead and plug in 7x plus 4 in the other equation. Everywhere you see a y, you're going to write 7x plus 4. So instead of x plus y equals 4, x plus 7x plus 4 equals 4. Now go ahead and combine some like terms. 8x plus 4 equals 4, and when you subtract 4, 8x equals 0, so 0 divided by 8 is 0, x is 0. Now it doesn't matter which equation you pick when you go back, when you plug in x is 0, you should get the same thing. 0 plus y equals 4, that just means y equals 4. So 0, 4 is where those two lines intersect. Number 3, solve by elimination, and it's already set up for you, so when you add these two equations together, look what happens. 1x plus 1x is 2x, the y's go away, nice, and 19 plus -7 is 12. So 2x equals 12, that means x equals 6. Now go back to either equation, it doesn't matter. Let's do the top one. 6 plus y equals 19. When you subtract 6 on both sides, that means y equals 13. Number 4, when you add these equations together, nothing goes away, so you're going to have to do a little bit of work. First, I'm going to rewrite the top equation. Now I'm going to think, I want y's to go away. So what's the opposite of -9y? Positive 9y? How can I make a 3 a positive 9? Well, I could multiply it by 3, and if I do that to everything in the equation, then I'm not breaking any rules. So 3 times 10x is 30x, 3 times 3y is 9y, and 3 times 25 is 75. Now that I've got opposites for my y's, I add the equations together. 4 plus 30x is 34x. 61 plus 75 is 136. And when you divide both sides by 34, you get x equals 4. Now you got to go back and get y. I'm not sure which one's better. I'll use the bottom one here. 10 times 4 plus 3y equals 25. So 40 plus 3y equals 25. Go ahead and subtract 40. 3y is -15, so when you divide, now you have y is -5. Number 5, this is going to look a lot like slope-intercept. I'm going to go ahead and start at -4, put a dot, and then rise. My slope is 1 over 1, so start at -4, go up 1 over 1, up 1 over 1, up 1 over 1. And this is a dashed line because it's strictly less than, so you're going to use a dashed line. The last thing we need to do is shade, and to figure out which way to shade, go ahead and plug in the point 0, 0. Ask yourself, is 0 less than -4? I don't think so. So since 0, 0 doesn't work, I'm going to shade all the points on the other side of that line. So I'll shade away from 0, 0, and now I have down here all the points that would satisfy that inequality. Number 6, I've got 2 lines, so I'll go ahead and do the first one, start at 3, and then go up 4 over 1. That's slope-intercept. That is also a dashed line because it's strictly greater than. The second one, when you start at -1, you go down 2, right 1, down 2, right 1, down 2, right 1, and that is a solid line. So I have my 2 lines, now I need to figure out which way I need to shade. For the top one, I plug in 0 for y and 0 for x. Is 0 bigger than 3? No. So for this one, I'm going to shade away from the origin. That's to the left here. And for the second one, when you plug in 0, 0, is 0 greater than -1? Greater than or equal to? Yeah, 0 is greater than or equal to -1, so I'm going to shade towards 0, 0 for this one. That's to the right. And now what I'm really looking for is the overlap, and in the overlap is this top section here. So now I have my solution set, And I'm on to station number 4.